Swayam Prabha, free DTH channel for education.
So today we are going to talk about once again the second order linear ODE with power series method and Frobenius method, and then we are going to talk about using that method we are going to deal something called legendary equation and Bessel's equation, which we will deal with it. Okay, so we are going to discuss about again the power series method or Frobenius method. Okay, in general. So let us have a quick recap of what we did in the last class. Okay, so we had something like Frobenius method we have discussed, for which we defined the analytic. So analytic means it is said to be analytic at a point x equal to x naught. If we can write it as a power series expansion, means summation n equal to 0 to infinity a x minus x naught power m, then we say that it is analytic at that point. Now if it is expand, if we can say that in the domain it is true for all the x naught, okay, then we can say that it is analytic at in that domain. Okay. Similarly, we can define the ordinary and singular points. So ordinary points means if you have this second order linear ODE y w dash plus p of x into y dash plus q of x into y equal to r of x, where if p x equal to x naught is analytic at p of x and q of x, then we say that it is ordinary point. If it is not p of x and q of x are not analytic at x equal to x naught, then we say that it is a singular point. Again, the singular point will be further categorized so that we have seen. So we have ordinary point, okay, x equal to x naught. Okay, we have two category. One is ordinary point, okay, another is singular point, and this can be again classified as regular singular point and irregular singular point. Okay, this we have seen. So now what I have another theorem. Suppose P, Q, and R, okay, P of x and Q of x and R of x are analytic in that given second order linear PDE, then we can say that there is one solution is going to exist, at least the solution is going to exist. Okay, the y of x is also going to be analytic, and that can be also represented by the power series. Okay, and that is going to be like the radius of radius of convergence for that x minus x naught is going to be positive. Okay, you are going to have a positive radius of convergence. Now next one, regular singular point and irregular singular point. So for regular singular point, what I have is that I have something like you have something called so p of x and q of x. So ordinary point, for ordinary point p of x and q of x would be analytic. Okay, p of x and q of x would be analytic, means you should have a power series expansion for this one. If that is not existing, then it is called regular singular point. Now in this case, what I have, suppose x minus x naught, okay, into p of x is analytic, and x minus x naught whole square into q of x is analytic. Then we say that this is a ordinary regular singular point. Otherwise, we say it as irregular singular point. Okay, that's what we have. Now next one, we are going to have we have discussed this one, Frobenius method. So where we have defined this equation y w dash plus p of x by x into y dash plus t of x by x square into y equal to 0, where px and cx are analytic at x equal to 0. Then we say that at least one solution is can be written in the form y of x equal to x power r into summation a into x power m, where r can be determined by it can be either positive or negative or complex number. Okay, and you have to choose your r in such a way that a naught is not equal to 0. Then the second solution again you can obtain the similar way, or you can get it in the using the logarithmic term which is going to go. So that we are going to see today, and then we derive this one, and then we mention that this is the initial equation r into r minus 1 plus b naught into r plus c naught is the initial equation we have mentioned. And then the Book's theorem also we have mentioned, like at least one of the power series will be applied using this when we are applying this Frobenius method. Okay. Now we are going to see what are the method, what are the solutions going to be. Suppose p of x and q of x are analytic at x equal to 0, then we are going to have this initial equation. The initial equation is r into r minus 1 plus b naught into r plus c naught equal to 0 is the initial equation. Therefore, it is a quadratic equation. Therefore, you are going to have two roots are going to come. So, since two roots are going to come, again you can discuss different cases, distinct roots, double roots, etc. So here we are going to discuss differently. Okay. So if R1 and R2 are two solutions, R1 and R2 are two roots of this equation, and they are not different. They are differing by not differing by an integer. Okay, R1 and R2 are two roots, and they are not differing by integer. not differing by integer. What is the meaning of it? Not differing by integer means, suppose I have R1 equal to 2 and R2 equal to 3. Okay, this is differing by integer. It is not differing by, we are expecting not differing by integer, but it is differing by integer. Means if I subtract R2 minus R1 or R1 minus R2, I should not get an integer. Okay, so it is not differing by an integer. Then in that case, it is going to say, okay, so case one is going to say, okay, case 1 is saying R1 and R2 are not differing by integer. Not differ by integer. Okay. So in this case, what I have, I have y equal to x power r1 summation m equal to 0 to infinity. Okay, y1 is going to be m into x power m is going to be one solution where am can be determined. Y2 is nothing but x power r2 into summation m equal to 0 to infinity am into x power. Different constant is going to come. Okay, so this is the solution for this problem is going to come. Okay, so y1, y2 can be obtained in this way. Now, if it is a double root, case 2 is double root. Okay, case 2 is double root. So double root means r1 equal to r2. R1 equal to r2. Okay, so in this case, it is going to become like y1 equal to x power r1. Okay, summation m equal to 0 to infinity am into x power m is going to be one solution. Second solution is going to be y2 is equal to y1 into ln x, okay, plus summation m equal to 0 to infinity, again x power r is going to come, okay, x power r1 summation am into x power m is going to come. Here differently, okay, am, capital A. Okay, so this is going to be the second solution is going to be. Now case 3, okay, case 3 is going to be as follows. So case 3, you are going to get R1 and R2 are differing by an integer. Okay, suppose R1 and R2, we have R1 and R2 differ by integer. That means this case I can take it. Okay, differ by integer. So in that case, what it is going to say, in this case, it is going to become like again same kind of thing. So y is going to become like y1 is going to be summation x, like here x power r1. Okay, m equal to 0 to infinity am into x power m, and y2 is going to become like k into y1 into ln x plus summation again x power r2 here. Okay, not r power 1 here. Here r2. Okay, r2 is there. I'll write it here. So here x power r2. X power r2 summation m equal to 0 to infinity am into x power. So the proof of the theorem is beyond the scope of the syllabus. So I'm just leaving it as you can just read other materials to get the proof of this theorem. Okay. So let us see some problems only. Okay. Let us see some problems and then solve it. How to get the answers for this one. Okay. Using this distinct roots, etc., we will find the answer for that. So let us find. Let me erase here and then let us find that answer for that given problems. So let us solve some problems. Okay. So what is going to be? So I have a problem x into x minus 1 into, okay, x into x minus 1 into y double dash plus 3x y dash plus y, 3x minus 1 y dash, okay, 3 into x minus 1 into y dash plus y equal to 0. Okay. Now we are going to solve this problem. Okay, so I'm going to see what is p of x. Okay, here b of x is nothing but 3x minus 1 divided by x into x minus 1. C of x is nothing but 1 by x into x minus 1. So clearly you can see that. Okay, clearly you can see that x equal to 0 and x equal to 1 are regular singular point. Are not an ordinary point. They are regular singular points. Okay. Now what I am going to do, so since x equal to 0 it is a regular singular point, I can apply the theorem and then I can find the answer for them. Okay, so therefore this is going to become like I can write this as I can convert this problem. Okay, let me convert this problem into this format. Okay, this is going to become like I can write this as y double dash equal to y double dash plus 3x minus 1 into y dash divided by x into x minus 1 plus 1 by x into x minus 1 into y equal to 0. Okay, therefore either I can write p of x here. So p of x is going to be 3 into x minus 1 divided by x into x minus 1. Okay, and q of x equal to 1 by x into x minus 1 I can write it. Okay, so you can see that P is not analytic at x equal to 0 and x equal to 1. Q is also not analytic at x equal to 0 and x equal to 1. Whereas x equal to 0, P is x into P of x is analytic. Okay, therefore it is x equal to 0, it is analytic, means regular singular point. X equal to 0 here is also not going to be problem. X square I can write. So that is also going to become like a regular singular point. Similarly, x equal to 1, again regular singular point, regular singular point. Now we are going to solve this problem. Okay, let us solve the problem. How we obtain solution for this. Okay, so now if you want to verify the other one, the theorem you have to verify. So P of x, what is P of x here? So if I want to write it in the P of x format, then I can write it as, okay, y double dash plus P of x by x plus C of x by x square. Okay, y dash here, y here equal to 0. So I can write P of x equal to, 3x minus 1 by x minus 1. Okay, similarly C of x equal to, okay, I can write it as x by x minus 1. Okay, so at x equal to 0, this is also analytic. At x equal to 0, this is also analytic. Therefore, this is going to become like, you can write this as, this is going to become like, you can verify that the theorem is going to be satisfied. Therefore, what you are going to get is that you are going to get, you are going to get, you are going to get, we are not going to get any problem over here. Okay, so, okay, so you can apply the theorem. Okay, you can apply the theorem and then you can find that. So that is that P of x, that should be P of x and P of x instead of Bx and Cx. Okay, so this is your P of x and C of x. That x is not there. Okay, x and x is not there. So C of x would be x by x minus 1. If you want to compare the this equation, then that is not the P of x. Okay, so now we are going to substitute. So therefore, the solution is going to exist. So your y is going to be x power r into summation m equal to 0 to infinity am into x power m. One of the solution is going to be. Okay, so now at x equal to 0, you need to find what is your, you can find your, if you want, you can find your b naught and c naught from here, and then you can obtain the answers for that also. Or we will go for regular way, we will use this one and then we will find that. So again, we will just keep remembering this one, y equal to x power r, summation m equal to 0 to infinity, am into x power m, y dash is going to become like m equal to 0 to infinity once again, m plus r into x power am into x power m plus r. Okay, y double dash is equal to summation m equal to 0 to infinity. Okay, m plus r into m plus r minus 1 into am into x power m plus r minus 1. Sorry, r minus 1 here, r minus 2 here. Okay. Okay, this is going to be your y dash and y dash. So let us substitute it here. Okay, let us substitute it here. So this is nothing but x square y double dash minus xy dash double dash plus 3xy dash minus y dash plus y equal to 0. So I substitute that. So therefore this is going to become like summation m equal to 0 to infinity m plus r into m plus r minus 1 into am into x power m plus r is going to come minus this is going to become like summation m equal to 0 to infinity m plus r minus 1 am x power m plus r minus 1. Okay, then I have 3xy dash, so that is going to become like plus 3 into summation m equal to 0 to infinity. Okay, m plus r into am into x power m plus r is going to come because x and m plus r minus 1, therefore this is going to become like x plus r. And again, y into, okay, therefore this is going to be like m equal to 0 to infinity m plus r, okay, m plus r into am into x power m plus r minus 1 is going to come. Then I have y, so that is going to become like plus summation m equal to 0 to infinity m plus r into am into x power m plus sorry. So this is going to become like summation m equal to 0 to infinity am into x power m plus r. We are going to collect the collect the least term. Okay, collect the least term here. The least term is x power m plus r minus 1 term. Okay, collect the coefficient of x power m plus r minus 1 term with m equal to 0. Okay, means you are going to collect the r power x power r minus 1 term. Okay, you are going to collect x power r minus 1 term. Therefore, this is going to become like minus r into r minus 1 into this is going to become like minus r equal to 0. Therefore, you are going to get minus r square plus r minus r equal to 0. Therefore, r is going to become like 0. Okay, r is going to become like 0 and double roots. R square equal to 0. Therefore, r equal to 0, 0. It's a double root. Therefore, you can expect that ln x is going to be ln x into something is going to be one solution. Okay. Now we are going to see what is the coefficient of x power m. Okay, x power m term I have to collect. Okay, so since r equal to 0, I can substitute everywhere 0 here. So therefore, this is going to become like wherever I have r, that I can remove. So wherever I have r, I can remove it because that is going to become like r equal to 0. So r minus 1. This is x power m. This is x power m is here. Here minus 1 is going to be there. Okay, this is going to become like m minus 1. Okay, and this is also going to become like m minus 1. And this is going to become like m, and this is going to become like m, and r is going to be root. Okay, this is going to be root. And similarly here, r is going to be root. Okay, now I am going to compare the x power m coefficient. Okay, if I compare the x power m coefficient, what is it going to come? Okay, that we have to see. Now you have to remember that here there is a small problem is here. What we have is that since I removed r equal to 0, this becomes negative. A power am x power minus 1 is going to come when m equal to 0. Therefore, this is going to become like m equal to 1 only. Okay, this is going to become like m equal to 1 only. It is going to come because at x minus 1 is not defined. Therefore, you have to rewrite this equation in this form. Now, once again, you can rewrite this one. Okay, you can rewrite this equation once again. So if I want to put it m equal to 0, as we did in the last class, okay, m equal to 0. Therefore, here everywhere you got to push it to m you got to push that to m plus 1. So m plus 1 into m into, okay, this is going to become like am into x power m is going to come. Here also this is going to become like m equal to 0. Therefore, this is going to become like, so here it is going to become like am plus 1 into x power m is going to come. Here also it is going to become like the same way, m plus 1 into am into x power m is going to come. Therefore, everywhere you have m here m plus 1. Okay, everywhere you have m plus 1 terms are there and m terms are there. Therefore, what I am going to do, I am going to write this equation as follows. Okay, so I am just going to collect this one. Here r is 0. So therefore, this is going to become like m. What I am going to do, I am going to collect the x power m terms separately. Therefore, this is going to become like m into m minus 1 into, okay, and then here am, this one. Okay, here also am, here also am. So therefore, this is going to become like plus 3m. Okay, and this is going to become plus 1 into am plus or minus, actually minus I can put. So m plus 1 into m minus m plus 1 into am plus 1. Sorry, plus is going to come because I have taken minus equal to 0. So therefore, this is going to become like m square minus m plus 3m. Therefore, this is going to become like plus 2m plus 1 into am minus m plus 1. I am going to take it out. Okay, m plus 1, if I take it out, this is going to become like again m plus 1. Okay, into am plus 1 equal to 0. Therefore, I can write am plus 1 equal to m square plus 2m plus 1 divided by m plus 1 whole square. So this is nothing but again m plus 1 whole square divided by m plus 1 whole square. Okay, therefore this is going to become like here am is there, here also am is there. Okay, therefore am plus 1 equal to am is going to come. Okay, am plus 1 equal to am. Therefore, what you are going to get, you are going to get your y is going to become like, if I substitute over here, already r is 0. Therefore, your y is going to become like summation summation am into x power m is going to come, where m is nothing but a0. Therefore, I am going to take a0 out. Okay, summation x power m is going to come, m equal to 0 to infinity. So this series is nothing but a0 into 1 by 1 minus x. Okay, where x is you should know that your x is defined between 0 and 1. Okay, otherwise it will not be valid. So you should be very careful with this one. So 1 by 1 minus x is going to come. A dot divided by 1 by 1 minus x is going to come. Otherwise, now y2 you got to find. Y2 is going to become like integral y1 into e power minus p dx divided by y1 square is going to come into dx is going to come. Now what is p? P is going to be here. So 3x minus 1 divided by x into x minus 1 is going to be there. Okay. So therefore what you are going to get? You are going to integrate p dx. So p dx is going to become like 3x minus 1 by x into x minus 1. That I can write as 2 by x minus 1 minus plus 1 by x. So you can see that 2x plus x minus 1, therefore 3x minus 1 by x minus 1 is going to come into dx. So this is going to become like ln of x minus 1 whole square. Okay. This is going to become like ln x. So therefore you are going to get ln of x into x minus 1 whole square is going to come. Okay. So if I just take minus p dx, so this is going to become minus ln 1 by x minus x square. So this is going to be e power, if I take e power minus p dx is going to become like 1 by x into x minus 1 whole square is going to come. Okay. So if I substitute over here, okay, so this is going to become like 1 by 1 minus x into integral 1 by x into x minus 1 whole square divided by 1 by 1 minus x whole square. Okay. So 1 minus x whole square, 1 minus x whole square cancel. So you are going to get 1 by 1 minus x into integral dx by x is going to come. So this is going to become like x into ln x into ln x by 1 minus x is going to come. Okay. So that's what we have. Okay, let us solve this problem. So I got to substitute that over here. So summation m equal to 0 to infinity m plus r into m plus r minus 1 into am into x power m plus r is going to come. Okay, because x square I am substituting, minus summation m equal to 0 to infinity m plus r into m plus r minus 1 into m plus r minus 1 into am into x power m plus r minus 1 is going to come. Okay, because here x into y dash and only one term will cancel, plus again minus summation m equal to 0 to infinity m plus r into am into x power m plus r is going to come. Okay, plus summation m equal to 0 to infinity am into x power m plus r is going to come. So I can sum these two terms together. So this is going to become like summation m equal to 0 to infinity m plus r into m plus r minus 1. Okay, m plus r minus 1 plus minus m plus r. Okay, plus 1 into am. Okay, minus I have one term here, summation m equal to 0 to infinity m plus r into m plus r minus 1 into am into x power m plus r minus 1. Now if I equate that, it is equal to 0. Now if I equate that to x power m plus r minus 1 equal to 0 when r equal to, when m equal to 0, that is going to be the least term we are going to get. So in that case, what I am going to have? I am going to have from this one minus r into r minus 1 equal to 0. Therefore, it implies r equal to 0 and r equal to 1 is going to come. Okay, r equal to 0 and r equal to 1 is going to come. So r1 equal to 0 and r2 equal to 1 again. So r1 is 0 and r2 is 1. So you can see that this is differing by an integer. Therefore, you can expect that ln x is coming over here also. So therefore, what I am going to put now, I am going to substitute r equal to 1 and then going to simplify this and going to see what is going to happen. So m equal to 0 to infinity. Okay, r equal to 1. Therefore, this is going to become like m plus 1 into m plus into m. Okay, into m is going to come. This is going to become like minus m plus 1 plus 1. Therefore, this is going to become like minus m. Okay, into am minus summation m equal to 0 to infinity. Okay, this is going to become like m plus 1 into m. Okay, r equal to 1, so it is going to get cancelled. So here it is going to become like x power m plus 1 is going to be there. Okay, here also x power m plus r is there. Okay, therefore x power m plus 1 is there. So here it is going to become like m plus 1 into m into am into x power m is going to come. Okay, x power m is going to come equal to 0. Now this one I can replace. Okay, m equal to 0 means it is going to become like m plus 1 into m into x power m mod unit is going to come. So I am going to put m equal to 1 to m plus 1 into m into m plus x power m is going to come. Now again I can push this to m equal to 0. So if I want to say m equal to 0, this is going to become like m plus 2 into m plus 1 into am plus 1 into x plus m plus 1 is going to come. Therefore, what I am having here m square plus m minus m into am minus, okay, Here it is going to become like m plus 2 into m plus 1 into am plus 1 is going to come. Okay, so that's what I have next slide. Okay, so therefore this is going to become like am plus 1. Okay, each coefficient you are going to equate to 0. So am plus 1 is going to become like m square am divided by m plus 2 into m plus 1 is going to come. Okay, so therefore you can see that when m equal to 0, okay, when m equal to 0, you are going to get a naught is going to become a1 is going to become like, okay, a1 is going to become like, this is going to become 0. Okay, when m equal to 0, a1 equal to 0. So a2 is also become 0 because a1 is 0. Therefore, you are going to get only a naught is going to survive, remaining all going to become 0. Therefore, what you are going to get here, if I substitute in this equation, okay, your r is 1. Okay, therefore you are going to get y equal to x power r into summation m equal to 0 to infinity am into x power m. Okay, here all the terms are 0 except a naught. Therefore, this is going to become like x power r into a naught. Okay, already r is 1 we got chosen. Therefore, this is going to become like a naught into x is going to come. Therefore, y is going to be this one. So y1 is going to be x is going to be that. I can choose a naught equal to 1. Therefore, y equal to x is the solution for this. Now let us go for the second solution. So if I want to find the y2, so if I want to find the y2 is going to become like y1 square integral e power minus p dx divided by y1 square is going to come. Therefore, sorry, here y1. Okay, so therefore this is going to become like x into e power minus p dx. So what is your p? P is going to be x by minus x by x into x minus 1 is going to come. So x cancel. Therefore, this is going to become like minus x by x minus 1. Therefore, integral p dx is going to be this one. Okay, so therefore this is going to become like 1 by x minus 1. This is going to be ln of x minus 1 power minus 1. Therefore, this is going to become like 1 by x minus 1. If I put e power p dx, e for p dx is going to become like 1 by x minus 1 is going to come. Therefore, I can put it over here 1 by okay. Actually, I got to put minus here. Okay, so e power minus p dx if I put, this is going to become like so minus p dx if I put, this is going to become plus. Therefore, this is going to become like ln of x minus 1. Therefore, this is going to become like x minus 1 only. Okay, so therefore this is going to become like x minus 1 divided by x is like x into ln x. Okay, and then this is going to become like plus 1 by x into dx equal to come. Therefore, this is going to become like x ln x plus x is going to come. Okay, so y2 is going to become like this is going to become like 1, not like 1 is going to come. Therefore, your y in general you can write as c1 into x plus c2 into 1 plus x ln x. Okay, this is going to be one general solution. So we find both solutions.